Welcome everyone to this session. My name is Uwe Hartmann, I'm CTO of Image Engineering, and in this talk I also have a second role. So I'm also the head of the standards department at VCX Forum. And in this session I'm going to talk about what is VCX and how does VCX work. Okay, so VCX was founded as an industry organization. It's a non-profit organization that is dedicated to create an objective assessment of mobile phone cameras, or of cameras in all, but at the moment it's focusing on mobile phone cameras. So VCX is formed by the members. The members are representing the huge majority of all manufacturers, or of the total amount of handsets sold. So you see here some of the members, but also keep in mind some members are a little bit shy, so they don't want to have it publicly announced. But be assured, the combination of all members and the sold handset makes a huge majority of all handsets sold. So VCX Forum was formed to do the assessment of mobile phone cameras in an objective way. Historically, it was formed between Vodafone, a German-based service provider, and Image Engineering. And when we showed the results and the procedure to our customers or to partners, they all said, oh, they were all eager to learn about it, especially to have some metric to communicate the quality of a camera in an easy way, but specifically also in an objective way, so that it's not about, hey, some person said this is good, but that really is like, hey, according to a test procedure that was formed by the industry, this is a good camera, or this is a very good value for the very good value. So it might be that your camera is not top-notch, the best of the best, but it might be that for the market segment that you are in, it is really good. So that is also something that VCX can help you with. So VCX is formed on 5 main tenets. So where we want to that we are base our work on. So first of all, it means that that all measurements, we ensure that it's an objective measurement. Objective in a way that for no assessment someone has to give a subjective score. Of course, in the weighting system itself, there is some subjectiveness in there, but that was an agreed subjectiveness from all members. So all members decided how important is noise over texture loss, or how important is color versus resolution, which is backed by some scientific work, but at the end also involves some subjective decision making. And but that is not per device, but for the entire test procedure. So also VCX shall give you the 100% user experience. So it's all designed not as a way to give you maybe as or the sensor manufacturer or the chipset manufacturer a tool to completely understand their own product and to say what is the best possible if I tweak it like this. It can be used for that, but that's not what we want to publish. What we want to publish is the user experience. So get the device out of the box, turn it on, and use it. And we know, especially for mobile phones, that hardly any user will fiddle with the settings. So they will use it as is. So that's also the way how we test it. VCX is open and transparent. So whoever would like to join can join this organization. And it is transparent. So the process, how a device is tested and how the score is created is transparent to the world in that extent that we exactly say what are the tests that we do. And it is 100% transparent to all members in really understanding how is the score exactly calculated. So it is not that just 1 or 2 people thought about it and then say, okay, this is the truth and this is fixed. It's open for discussion internally, but of course also feedback from outside is always considered. The tests for VCX can be performed in a typical imaging lab. The VCX forum has, as organization, different level of lab authorization. So the top is the trusted labs, and the trusted labs, so we have one in Germany, one in Finland, or others are on the way to apply for that. So these trusted labs have shown their technical capabilities, but also their independency from certain manufacturers, so that they can test the devices, and all devices that are on the website of VCX that are published under the brand name of VCX have been tested in either of these trusted labs. And we want to have VCX shall continuously be developed. So you might have heard about VCX earlier and about the test procedure, but I can say now we have a new version. It's the version 2020 of the test procedure, and we just started, after we finished the work on version 2020, we just started the work on the new version. So there will be even updates. We will continuously check if everything works the way we'd like to, but also we will work on adding new additional test items to the test protocol of VCX. Question that we regularly get: why do we need a new test procedure? There's already DxO Mark, there's CPIQ. Why was there a need to form VCX Forum? So all of you that work in the industry of mobile phones might know a little bit about the other organization. So IEEE CPIQ. So it started very ambitious, and they wanted to create a complete test procedure, but so far it lacks the completeness and the majority to be the complete test procedure. So there has been interesting work been done, but it's not finalized, and there is no rating system. So at the moment it is only a way to create a metric, but not to make that a score. So that's not what we can use. And then we have DxO Mark, a very interesting and test procedure, of course, but as you have seen, our tenants, it does not really follow these tenets. So we want to say, for example, that we are completely independent and that we are completely transparent and open. And DxO Mark is a profit organization. It's a company. They want to, of course, earn money. So that's why they are structured in a different way. VCX Forum is non-profit and has the transparency on their flag. But DxO, so you don't really know exact the procedure. There are some information, but you don't know the exact procedure. And you cannot go into your own lab, test the camera, and predict and say exactly, okay, this would be this and that DxO Mark score. You need to ship the device to Paris, and you need to pay a lot of money to get a score, but you cannot predict. Even if you buy the expensive test equipment, you're not able to predict the score, DxO Mark score. You can do that with VCX. So if you follow the test procedure, you have the equipment, and as a member, you have all the tools. You can say, okay, according to my test, I come to this score. And then it might be a device-to-device variation to the trusted lab, but in general, you know what you will get. You can develop with that transparency in mind. You know what is important, and that is a big, important factor in comparison between DxO Mark, CPIQ, and the VCX score. So VCX always wants to have open and transparent processes inside the organization. So we continuously do research and want to further develop the score. So we just started with that, with the goal to have new metrics and reviewed metrics in the next version. So with that, we always have a review and a score system so that we continuously work on that. And not only a single company or a single person, but always all members together. So what is it all about? So at the end, the VCX forum creates a test procedure, but also tests devices. So handsets get to the trusted labs, and then the results are published on the website. So vcx-forum.org. That's our website where you can get the results, and you can also have a look at detailed per device, so that you get the score, and you get the score also a little bit in a little breakdown, so that you can see, for example, image quality, performance, and these things separated. So that is where the score is used. Of course, members can also use the logo, for example, to put it on their box or to use it when presenting a device. So members can use the logo and the trademarks of VCX to express to their customers or to their development partners about the performance. So where VCX results are also very often used as in kind of a currency, so in the work between a manufacturer and a supplier, so that you can say, okay, I want to have a certain module and I want that this reach a certain VCX score. And with that, you have a very reliable number to describe the performance, which you can actually make contracts with. So very useful also in that area. Okay. When I say we are always seek improvement, and it's an open and transparent process, I can say it's all based on as much independent data as we can get. So there are statistical analyses, so scientific papers that are published at various conferences that we take as input. There are data that we derived ourselves. So when we do subjective studies, we typically have nearly 50 companies with providing data, or 50 people in a huge variety of companies providing actually subjective data for creating data to evaluate the performance of our metric. Members can contribute or do contribute with like market research data, or we collect data that we can get from other consumer research organizations. And of course, scientific papers that technically are always carefully reviewed and then maybe even included into the test procedure. So where like peer-reviewed papers show a new interesting metric, we also gonna have a look at that and review that. And internally, when we develop the score, it's not about, someone says this is good enough. It's about comparing the results with data that we gained, like people checking images visually, and then we compare with the objective data. That's data-driven development inside VCX Forum. Okay, how do we actually test a mobile phone handset? So, first of all, we have to set up the device. So that means that we do have some, we go into a lab, and the lab has to fulfill certain criteria to be also certified and to be allowed for VCX. So we need some kind of climate control. The illumination needs to be controlled in a very good way in terms of uniformity, intensity, and so on. The device will be, as soon as we get it for test, it will be reset to factory default settings, and that will then be tested. And before we start the test, we will update we'll apply the latest updates that we can get, and then it will be frozen. So when we publish results, it will be on that state at which we could test the device. You know that there are continuously updates, but we have to test at one phase, and we try to make sure that the software on the device that we test is final user software, so that that is the software, the firmware that the user will also experience. So we don't want to test devices that are like 2 months before release, because there will too much to change. So it's not a valuable information that we can get. Okay. When we test, we will test under different lighting conditions. So when you maybe you have already studied VCX earlier. So in the version 1.5, that was the previous version, we had specified some lighting conditions. But with the version 2020, we also had to take into account that devices get better over the years and that devices changes. And we had, for example, lighting conditions that did not change the spectrum, only the intensity. So this was a clear path to update that. So that means that today tests with the devices according to VCX test procedure are performed under bright light. So, for example, for image quality, still, for video image quality, for selfie and for zoom, that is a D55 2000 lux lighting. Then we have a medium light condition, that is a 250 lux light condition with a neutral white LED illumination. So that's also used in various test conditions. And then we have the low light condition, which is 10 lux with a warm white LED. So we have chosen these spectra and these intensities according to our experience, how devices are used. Especially the low light was a discussion, but in the previous test we had 60 lux or 63 lux as low light, and we have seen that the engineers, the brilliant engineers of mobile phones, just managed to, with nearly all devices, that even at 60 lux they can get reasonable good images. So that's why we lowered to 10 lux to differentiate between devices. And we see that this is actually the experience of users, or the expectation of users, that even at something dim like 10 lux, they would like to capture images. And interestingly, a lot of devices show really good performance at 10 lux, but even lower than that. Then we have flash. So devices do have a flash. So we test under the low light condition. So at 10 lux, we activate the flash, and then we also check the performance under that condition. We will, that are the different light conditions where we test like image quality, video image quality, zoom, and the selfie camera. Then we also test the device under 4 times, or with the 4x zoom or with the 4x zoom, selfie, video is under these 3 light condition, bright, mid, low. And then we additionally have an extended low light condition. So what does that mean? We do have, we will have another session about low light performance, and the shown procedure in the other session of low light performance is exactly applied at VCX. So we test the device under we capture images under 10 lux, 7.5 lux, 5, 3, 2, and 1 lux. And then we track different image quality parameters under these, from these lighting conditions. And whenever a threshold is reached, regardless of which KPI, that is stopped. So a device that has a 5 lux low light performance means that that below 5 lux there will be a significant image quality issue, either too much noise or too much texture loss or too low resolution, so that it is stopped there. So that's the low light performance or extended low light performance that we actually measure. So what equipment is actually used for performing a VCX test? So all equipment can be obtained through image engineering. First of all, we use test targets, and the main target, you will see in another slide, is the TE42 low light. So it's a multi-purpose test target that features many different patterns to evaluate different aspects of image quality. That will be used in different aspect ratios, so 4:3, 16:9, and in a smaller form factor for the selfie camera. And then we have a TE269, which is a high dynamic range OECF test target, transparent, which is then also used for the dynamic range testing. We have, for the timing measurement, we do have an LED panel. So it's a small timing measurement device from image engineering. And we combine that with a near focus target. The near focus target is at the moment in the trusted labs only. It's under development, but it will be commercially made available rather soon. And then we have a camera shaker. So for the motion test of like optical image stabilization, we use a device called Steve that has can controlled shake the camera or simulate a handshake. And yeah, so that is then also used for the motion measurement. For the analysis, we use the IQ Analyzer. It's a software product of image engineering that gets the images from the different targets and then can output an XML file. And that XML file is then the input for the tools used by VCX to generate the score. And then we have the, for lighting, we use the only product on the market that can fulfill all the requirements, and that is the IQ Flatlight. So it can go on the target from 2000 lux D55 to 1 lux low light performance. So it's a huge intensity range with a controlled spectrum, and so that's the only product on the market that we see that can fulfill these high requirements in terms of intensity range, in terms of spectrally or spectral quality, and stability. And so that is used in the trusted labs and in all other labs. So the IQ Flatlights. And then, of course, you need some equipment around. So there's the VCX tool, which is a software Python tool, or a software tool based on Python that will collect all the XML files from the IQ Analyzer and will generate the score. So this is a tool maintained by VCX Forum, developed and maintained by VCX Forum. And of course, you need some further typical lab equipment. So you need some mounting for the chart, for the camera. You need light measurement equipment because you want to verify intensities. And you also need like an LE7 integrating sphere for back illuminate the transparent test target. We define also different viewing conditions, so things like visual noise and some metrics require definition of viewing conditions. So we have three. We have the viewing condition 1, which is 100% view on a monitor, so basically worst case scenario. We have the small print as viewing conditions 2, so basically the entire image is shown on a small mobile phone screen, and then we have viewing condition 3, where the entire image is shown on a PC screen, a larger screen. Okay, how do we capture, what is the process? So we capture the device or the test target. So you see here the device is mounted on a tripod during the capture procedure, and then it reproduces the TE42LL, as you can see in that part. Oh, actually, I see that is showing the TE42 version 2. It needs to be updated, that image. So, it's here. There you see actually the TE42 low light in the selfie test. So, for the selfie camera, we use a smaller target, as the large target might not be in focus of non-autofocus selfie cameras of maybe entry-level devices. The dynamic range is then tested using the LE7. So you take 3 different kind of images and 10 each. So using that specific test chart or that combination of LE7 with the T269, so high dynamic range test target, that is then reproduced by the device under test, and then we will touch, or you select touch AF or touch auto exposure a different region of the target, and that as a combination will then be analyzed. The timing measurement is performed or has been significantly updated between the version 1.5 and the version 2020. So we actually measure now the shooting time lag and the frame rate. And for the shooting time lag, actually we have a near focus target and a far focus target, and we will we remove the near focus target, get it out of the way, and then we have a controlled focus between near focus and far focus target. So with that, we get rid of the human factor. It's all automized, and we can do the measurement. So you see there are the LED panel. Product of image engineering is included into that setup. That is actually which performs the measurement, or where you can measure the time, and then the performance is measured using the near focus target. So this is this case is the near focus target is actually on the up. The camera can focus on it, and then the focus target will fall down and make its way to that the camera can have a look on the far target. And there we can also measure the resolution, so that we keep track if a device is only focusing very fast or if a device is also in focus in terms of resolution. Okay, then we have a device on Steve. So that means that we will have the device with a controlled handshake, and other than in version 1.5, we actually capture images of the TE42 test target, so that we have a much more complex description of what's going on in the camera. So we can measure texture and sharpening and these kind of things more precisely than we could before. Using that target. After all tests have been performed, as said, the VCX tool will collect all XML files from so the images will be analyzed with the IQ Analyzer software. Then that creates XML files, and then the VCX tool will collect all these files and create the score. So these score can then go onto the website or can be used then for further reporting. So let's have a little or closer look on what are we actually looking at when we talk about like image quality. When we test image quality, we have a look at resolution, texture loss, sharpness, color, visual noise, dynamic range, shading, and distortion. So all comes from the T42LL, the target that you actually see here. So for resolution, we mainly have a look at the effective pixel count. So we measure the MTF10 from the sinusoidal Siemens star. So you heard about that in the resolution section. And then we calculate the MTF10, take that as limiting resolution, and from that we calculate the effective pixel count. Basically, you can say the effective pixel count is, in contrast to the theoretical pixel count, the number of elements that you can really resolve. So it could be that you have a theoretical 12 megapixel, or you have 12 million pixels, or you have a 12 megapixel device, but that the resolution is relatively poor, so you have an effective pixel count of just 8 megapixel. That can very typically happen. Okay, then we have a look, very important, at the texture loss. So we use the dead leaf structure and the dead leaves Croft method there to analyze the texture loss. So extracted from that target, we also get the SFR, and then we can measure the texture loss. We have many slanted edges in the test target. We don't use it for resolution measurement, because we think that slanted edges with mobile phones is a problem, because they are so much influenced by sharpening. But as they are influenced that much by sharpening, we can actually use it for that, so that we use the slanted edges to give a score or to measure the sharpening, undershoot and overshoot, and that then can go into the score. We have 96 different color patches in the T42 lowlight. So these are analyzed, and then also a color reproduction measurement is performed. We are, of course, aware that a camera is not designed for perfect color reproduction. It's not a scanner. It's supposed to take pleasing colors. But of course, it's valuable to do this measurement, as we can see like outliers, or if there's a significant color issue, so that like all blue colors do have a cast, or these kind of things, we can actually see that in the results. Then we have the so-called visual noise. So it is a metric that describes the perception of noise for a human observer. That's where the viewing condition comes into play that I explained earlier. So the higher the visual noise, the more noise we see. It's measured on the gray patches in the T42 low light test target. Then we measure the dynamic range. In the version 1.5, we measured the dynamic range on the T42 test target. And of course, we knew that the dynamic range of the target is limited, but we said, okay, if a device is better than the dynamic range of the target, it will reach the dynamic range of the target. So that's why we just said, okay, as soon as it has a dynamic range of the target, it gets maximum score, there is no problem. But with today's mobile phones, with intensive scene adaptive processing and scene adaptive rendering of the images, we have seen that if there's not enough contrast in the scene at all, it might be that the measured dynamic range is even lower than that. So we had devices that showed a very low dynamic range on the test target, on the T42, but as soon as we provided more contrast to the camera, it also managed to reproduce that contrast. So that's why we test now using the high dynamic range test chart, as you see here. So the T269C test chart, which features a huge dynamic range of more than 134 dB, so nearly 5 million to 1. And we then have different measurements where we touch the different areas of the target to force the camera into a different exposure, and then we use all images to give a dynamic range metric or dynamic range score. We have a look at shading. So as we measure under different lighting conditions, we also have a look at the shading. And there is the intensity shading and the color shading. Especially color shading is updated for the test procedure because now we measure at different lighting conditions. And as you have seen, we have, for example, daylight, where we have, because of the powerful light sources, flat lights, we have also an infrared content. And then when we have a look at the neutral white LED, we have no infrared content anymore. And that is a huge challenge for mobile phone devices to work with these different kind of illuminations. And that's where we might see or can see more color shading. And so, but that is really what users also experience. So that's what we have a look at. Okay, and then we have a look at the distortion, the relatively simple TV distortion measurement, so that we have just the height in the center and in the corner. Of course, you can do more complex measurements than that, but for the user experience, and we decided that that is sufficient for today's mobile phone devices. This is at the moment, or this is the TV distortion. Okay, and so at the end we sum up all the scores, all the data, all the metrics go into the tool, and the tool will then create the final score according to a certain weighting. So every metric is converted to a score, and then this score is then goes with a certain weighting into the total score. So that is the process to get to the entire score, but that also means that we have very fine control over every parameter, how it contributes to the total score of total VCX score. In general, you can say that the main camera has 80%, the selfie camera 20%, and then within the main camera we also separate between like image quality and performance and so on. So this way we distribute it, and the weightings are not made up out of nowhere. It's also based on known statistics about devices and how people use them, how people actually. So how many low light images are captured, how many bright lights are captured. So user statistics have been used also to give a certain weighting here. And then, so that gives the total score. Some more details about the score generation. So every score has a lower gating and a high gating criteria, so that we decide what is the best possible or when does not have more benefit to the user. So as soon as we reach a certain level where we say, okay, if it's this or better, this is the best user experience that you can have. So then that's the higher gating criteria. The lower gating criteria is, okay, what is the level where it's not acceptable anymore, where it should get no score at all? That's that. And we can then convert that with these gating criteria and a certain formula, depending on the metric, we can convert into the score. It's worth noting, it's not so the score per metric can be positive and negative. So for some key contributor to image quality, for example, texture loss, we also can get you can get negative scores of the device. So if a device has huge problems with texture loss, it also gets score deducted because it might be that if you have a device which has extreme noise reduction and lots of sharpening, it might that it gains some score in terms of resolution because the high amount of sharpening, but then we want to reduce that because texture is bad and sharpening is high, so we reduce that so that a device with actually poor performance does not get a high score. That's why we have sometimes negative scores included. Okay, so that was a quick run through VCX forum. If you are interested in get in touch with us to get more details about that, go to the website vcx-forum.org and collect details, and we are happy to provide more information. So thank you for this participating in this session, and talk to you soon. Thank you.